Hi, what's up guys? Welcome to Chewable Math. My name is Chandra and I'm so excited to share this lesson with you. Our menu for today is this big cake called the trapezoidal rule. Since it's a big cake, we're going to cut it into several tiny parts. First, we will rediscover the trapezoidal formula, then we'll find out how to find the heights and the bases of the trapezoids, and then there's this little trick called the dummy trapezoids. Finally, as a bonus, I will show you how to work on the trapezoidal rule effectively with some Casio calculators. So stay tuned for more, and I will see you guys right after this. Alright, a little background before we go any further. First, this topic is usually taught in AP Calculus class, right after the Riemann sum as a part of the intro to the integral concept. Second, there's actually nothing fancy here, it's just a method to approximate the area under a curve by using a bunch of trapezoids. While this method is a little bit tedious, yet it doesn't give you an exact area. So you will appreciate the integral more since a definite integral could give you the exact area under a curve. Okay, first let's recall the concept of trapezoid that we learned in the geometry class. In case you already forgot, a trapezoid is actually made up of two triangles. For the sake of simplicity, let's call the first one the upper triangle and the second one the lower triangle. Each of the triangles has their own corresponding bases. Let's call them A and B. Both of them have the same height. Let's call them H. Since the area of a triangle is simply half of the product of the base and its height, we could count their corresponding areas. So the upper area equals to half of A times H and the lower area equals to half of B times H. So if we merge these triangles back together, the area of the trapezoid is going to be the sum of these two triangles, which is half of A times H plus half of B times H. Sometimes it's easier to simplify this as H over 2 times A plus B. Okay, so what is so difficult about the trapezoidal rule? Well, the trick is not just about understanding the trapezoidal area, but it's also about how we could see these trapezoids to be contained within the curve. Even though this method is just basically about adding up a bunch of trapezoidal areas, there is a catch. Well, in fact, there are several. The first catch is you have to remember that the trapezoids are going to be rotated. So the parts that seems to be the bases just because they're horizontal, they're actually the heights. The bases and the heights are somewhat quote-unquote switched. Now let's see how the trapezoids are actually being used to approach the area of a curve. We could see that we have four trapezoids that tries to approach this function fx. Now it is important to notice that these trapezoids in the middle are somewhat arranged back to back. So what seems like a base of a trapezoid is also a base for another trapezoid next to it. It's also important to notice that all these trapezoids have the same heights, so let's call them h. In fact, the trapezoidal rule only works if all the heights are the same. Okay, so let's figure out the areas of these multiple trapezoids. So we have the first trapezoid on the left, that's half of h times a plus b, and then add it with the second trapezoid to add it with half of h times b plus c, and then add it with the third and the fourth as you may have known how to do it. Now if you notice, the expressions have the same terms, which is h over 2. Let's factor it out so we can rewrite the expression like this. Last thing, since that leaves us with 2b's, 2c's, and 2d's, we would like to simplify them again like this. Finally, I want you to focus on that last expression because it's actually the formula of the trapezoidal rule. If it looks complicated, let me help you to remember this easily. We always need to count the coinciding bases twice, which are b and c and d. While both of the bases on the edges, a and e, they're not coinciding, so they're only counted once. Okay, to make sure that you guys got that part, let's do an example. Find the total area of the figure on the left with the trapezoidal rule. We could see that now we have 5 pieces of trapezoids, but the concept is pretty much the same. Since we already have all the information we need, let's just use the formula. So the area is equal to half of the height, which is 3 over 2, times the sum of the bases. The first base on the left edge, 15, is only added once, right? Then add that with twice of the coinciding bases. So we add it with 2 times 8, and then 2 times 12, and then 2 times 10, and then 2 times 14, and finally, since 13 is on the right edge, it's only added once. Now let's count the ones in the inner parentheses first. 2 times 8 is 16, 2 times 12 is 24, 2 times 10 is 20, and 2 times 14 is 28. And then add all of these guys, which is 116. And then finally multiply that with 3 over 2, that makes it 174. So the total area is 174. That is pretty straightforward, right? So next, I want you to do it yourself. This is the first piece of the concept. Why don't you take your time to do it yourself and pause the video? And the answer is 31. So applying the formula is quite simple, right? Is that all? Okay, let's get real. I already mentioned that the first catch to applying the trapezoidal rule is remembering that the trapezoids are quote-unquote rotated. Now the second catch is you won't have information about the heights. Instead, you will have information like intervals and subdivisions. Okay, probably they sound intimidating, so let's get to the bottom of this. First, let's discuss about the interval. Sometimes I like to use the word boundary to describe intervals. Boundaries are basically the point where you start and where you end. In this case, you start from x0 and ends at xn. Next is the subdivisions. The number of subdivisions basically tells you how many pieces of trapezoids that you want to use. We usually use the variable n to refer to the subdivisions. Now that we got the interval and subdivisions covered, we're ready to find the heights. Do you still remember that the heights are basically the horizontal parts? But before that, we need to count the interval length first. We do that by subtracting xn with x0, or simply the greater number with a lesser number. Finally, we could find the height with dividing the interval length with the number of pieces that we want, which is n. Hopefully that sounds simple enough. Let's do another example. With the interval given on the left figure, find the height for the trapezoidal rule with 7 subdivisions. So the problem is telling us to divide the interval into 7 pieces. Since the interval length is the difference between 29 and 8, we just need to divide that with 7, which then equals to 21 over 7, and it simply equals to 3. That's it, you could do it yourself too, right? That means you're ready for the second piece of the concept. So why don't you take your time again and pause the video? And the answer is 2. Okay, you're almost there. This last part is actually the exhausting part because we need to find a bunch of numbers. But don't worry, I will give you a trick later to deal with this quickly. Let's recap what we've learned so far. We already know how to count the interval length from 2 given points. We also learned that dividing that length with the number of subdivisions will give us the height. Now we will use that height to find the other points so that we can find the bases. Simply keep adding by h until you get all the points that you need. Keep in mind that if you're dividing into n subdivisions, then you will need n points plus 1 extra point. For an example, if you're dividing into 5 subdivisions, then you will need 6 points. Now, I bet you still remember about the functions in algebra class. An x point will correspond to a y point. In this case, x0 corresponds to f of x0. And you know what? That value of y is actually the length of the base. Other points will also correspond to the other bases. So how should you find these points? Well, the most straightforward answer is of course by substituting the x value into the function. Let's just show that concept with example 3. With the interval and function given on the left figure, find all the bases for the trapezoidal rule with 6 subdivisions. Okay, since we are going to divide this interval length into 6 pieces, that means h is equal to 4 minus 1 divided by 6, which is half. That means we're going to keep adding by half to get the consecutive points. Notice that we already have 7 points, which is 1 extra point from the subdivision. Next, we need to substitute those points to the functions to get all the bases, which are a through g. Since substituting is fairly simple, I'm going to skip the process. I already counted those numbers ahead, so these are the bases. Now that is the third piece of the concept. As usual, take your time and do this by yourself. Pause the video and I'll give you the answer after this. And the answer is 1.816. Congratulations, you already passed the most annoying part. Since we have done most of the heavy lifting, it's all downhill from here. You just need to put all the pieces of the concepts together. But first, let me share a thought. Do you realize that you don't even need to graph the actual function? That means we could just actually draw some figures that somewhat resemble a stack of trapezoids. So as long as you draw the right number of pieces, the right heights and bases, then you are good to go. So let's do one last exercise that summarizes all of the pieces of the concepts that we have learned. But we will do it this time with a scientific calculator. I'm going to use these two calculators. First is the Big Brother Casio FX9860 GII. It's my favorite. It has tons of useful tools and it could really help you to save a lot of time. The second is the Little Brother Casio FX991ES. It is quite decent, it could get some work done, but of course not as much as the Big Brother could. If you own one of these, you could use it to help you with the trapezoidal rule. Of course, other calculators might work too, but I will just cover these two calculators. Example 4. Approximate integral 0 to 1 of sine square x dx using the trapezoidal rule with n equals 4 to 3 decimal places. Alright, I'm switching to my iPad and calculator now, but on this section I will talk through the captions so that you can focus more on the screen. There you go. I hope that you guys could learn new tricks from that particular part. Since I think that's already a lot to digest, I will cover the FX9860 GII part on another video. Spoiler alert, it's gonna be so much easier, you won't even need to copy the numbers like this. Now it's time to put all the pieces together. Take your time and do this last exercise by yourself. If you could, also try to use the calculator tricks as well. Pause the video and I will give you the answer right after this. And the answer is 19.9719. So that's it. I hope you guys enjoyed this video. If you like it, give it a thumb, write your thoughts on the comment section, and share this to anyone who would probably need this. I'll see you guys later on another Chewable videos. Until then, take care.